Today we're going to start with section 4.1, and it's titled Divisibility. We're going to talk about how we look at numbers and know whether or not they're divisible by smaller quantities. In particular, some single-digit numbers, and the answer, because I stuck it in my calculator or I long divided it, is not what our goal is. Our goal is to be able to do that without those kinds of things, either because it would take a long time to do it by hand, or because the technology is either not readily available, or you're working with it with small children, which means they probably are not using the technology. Calculators in first grade is probably not what we're going for. So that's what we're going to be looking for, okay? All right, so to start with, we're going to talk about what we mean by divides. If A and D are whole numbers, then D divides A. This notation you may or may not be familiar with. It's a little confusing because it looks like a fraction, but we read it as D divides A. So if you think about it in terms of a fraction, it's actually backwards notation. The first number is like the divisor on the denominator, and the second number is actually like what we're dividing. If and only if there's a unique whole number Q, such that A equals DQ. If D divides A, then D is a factor or divisor of A, and we say A is a multiple of D. And I'll write out one with numbers here after you get the blanks filled in. So you're going to use the example of 20. Give me a number that divides 20. 5. Okay, so the way we would write that is we would say 5 divides 20. Okay, that's how it's written. And why does 5 divide 20? Well, because there's a number 4, which when multiplied by 5 gives me 20. That's why it divides it. There's another number that if you multiply it by that, you get back to 20. And I don't know that I have it written down later, so we'll do it right here, right now. Give me a number that doesn't divide 20. 6. If we wanted to talk about 6, we would say 6 does not divide 20. So it looks like the divide sign, that vertical bar, but we put a slash through it, just like we would for like not equals, or is not an element of. We've used that before. So that's the symbol for does not divide. Theorem 4.1 says that if you have any whole numbers A and D, where D divides A, and you have another whole number N, then D will divide NA. And we can look at that same example that we saw before with 20, right? We said that 5 divides 20. Well, that means that 5 is going to divide 20 times anything. Anything has to be a whole number. But if you multiply 20 by 2, you get 40. Is 5 going to divide 40? Yeah. If you multiply 20 by 7, you're going to get 140. Is 5 going to divide 140? Yeah. And the reason it's going to is because 5 is already a factor of 20. It doesn't need to even be a factor of the other piece. Allison?
Is it not difference for D divided by NA or D divided by AN?
Like,
Just like the
oh, NA or AN down here at the back? Not at all, because multiplication is commutative. Yeah, so you could write it the other way. Yep. Okay, you have 5 different properties you're going to write down, and so I'm going to flip the screen and let you write them and just be quiet while you do, because there's some details in them that you want to make sure you get signs right and things like that, and I don't want to be talking over you and distracting. So these are 4 different properties. Actually, I thought they were typed in here. Evidently not. I'll write them with you. Okay, here's the first one. Just be careful in your notation. If D divides A and D divides B, then D divides A plus B. And just to give you a real quick example, you know this works. It's like saying this. If 2 divides the even number 4 and 2 divides the even number 6, well, what happens when you add 2 even numbers together? You get another even number, so 2 will still divide that even number. And it's true for all multiples. It's not just true for 2's. Okay? If D divides A and D does not divide B, then D will not divide the sum, A plus B. Right? If you did even plus odd, that's not going to still be even, so it's not going to be divisible by the number 2. Doesn't work. Starting out again the same way. If D divides A, but again we're going back to now D divides B. And as long as we have A greater than or equal to B, and I'll talk about that condition in a minute, then D divides A minus B. The subtraction is awfully similar to addition. So it makes sense in some ways that these conditions match the first one and the third one. They seem quite similar. There's only one extra condition to make it true. And does anyone have any idea why that extra condition, A greater than or equal to B, might need to be there? Right, you got it. If we had B bigger than A, right, then A minus B would be negative. There's nothing inherently wrong with that, but our divisibility rules are set up still with working with whole numbers. We're not going to work with integers until we get to chapter 5. So it's not that it's not true, it's just that we're only working with whole numbers right now. That's the only reason that condition's there. All right, and likewise, if D divides A and D does not divide B, again, A is greater than or equal to B, then what do you suppose is going to be true about the divisibility here? Yeah, it doesn't divide. Again, it looks quite like number 2. Yeah? These two are sort of partners in crime. The last one is actually a third partner. That doesn't even make sense because partners are 2's, right? But pretend it's a partner to those as well. All it does is it says, well, what happens if D does not divide A then? It divides B though. It's just, switched. Well, it'll still be true, the same thing that's true on number 4. It will not divide. And the only reason these three go together, the only reason that doesn't happen with addition is because addition is commutative, right? A plus B is B plus A. So in some sense, you could reverse it and create a 6th one of these, but it would be exactly the same as the third one because addition is commutative. Now notice some of the things it doesn't talk about. It doesn't really talk about here what happens if there's multiplication involved, right? So like what happens if you multiply A and B? Well, if you multiply A and B, you're actually back at this situation right here, right? We already talked about multiplication. We talked about it more all-encompassing than this particular one over here, Theorem 4.2 did. It was sort of broken out in these little odd pieces. But we already talked about multiplication. We don't have anything talking about division, and there's just not anything for division, so that's why you're not seeing that happen. All right, we're going to move into some very concrete properties now, okay? These are the properties of specific numbers and whether or not the divisibility rules hold. So these three are grouped together because their divisibility properties are all quite similar. So sometimes I will ask people, how do you know a number is divisible by 2? And they'll say, because it's even. And then I'll say, how do you know a number is even? And they'll say, because it's divisible by 2. Like, that's not real good. That's circular logic. So this is a better sort of description. A whole number is divisible by 2 if and only if its units digit is even. And that's really important, right? None of the numbers before the units digit matter. It matters what it ends with. It ends with 0, 2, 4, 6, or 8. The divisibility test for 5 is almost identical. You just look at the last digit as well. You're just looking if the last digit's a 0 or a 5. And again, the divisibility test for 10, much the same. You're just looking at the last digit and it's a 0. It'll be divisible by 10. So those three get grouped together because all you're doing is looking at the last digit. The next two get grouped together because they're similar, but they do have a difference. The divisibility test for 4, a whole number is divisible by 4 if and only if the last two digits as a two-digit number is divisible by 4. So what does that mean? Well, it means we have this, long number, whatever, and it's got 5 and 4 and 3 and 6 and 2 and 1 and 8. That what you do is you look at the last two digits only, and you ask yourself, that number, what's that number I just circled? 18. Is 18 divisible by 4? And you would answer yes or no, and this one would be no. And if the 18, in this case, answer is no, then the value as a whole, the whole thing, it's also a no. You only have to look at the last two digits. That's similar to the 2's, right? In the 2's case, you only look at one digit. In the 4's case, you look at the last two digits. And then you look, for the 8's case, at the last three digits. Now, in some sense, that's useful, and in some sense, it's a little bit less useful than the others. For example, let's use this same one, 5, 4, 3, 6, and I'm changing the last three numbers. So if I'm looking at the last three numbers, and it's even, you at least stand a chance at being divisible by 8. If it's not even, you're already done. You don't have to consider anything any further, okay? But if it's even, which this one is, this one you can use this property for very quickly. Is 0, 1, 6, which is the same as the number 16, is 16 divisible by 8? Yes. So then this number, as ugly and long and whatever as it is, will also be divisible by 8. But let me tell you, if this 0 had been a 9, I have no idea if 916 is divisible by 8. I don't know my 8's tables up to 916, right? But if a child were doing this in 3rd grade, 4th grade, whatever, whenever they're working with their division for the first time, wouldn't it at very least be a lot easier to divide 916 by 8 than 5,436,916 to check? Yeah, it would. So it simplifies the process some. Sometimes it makes it super easy. You just know it. And sometimes it's still going to be a little bit of work. Make sense? All right, the next two rules we're going to look at are 3 and 9. Have anybody seen the 3's rule before? Even if you just read it and you cheated. I'm not talking about that. But have you seen it before today? How you know if something's divisible by 3's? No one has? I didn't encounter it until, I think it was early high school. And I thought, who didn't tell me this along the way? Because that would have been so helpful. All right, so divisibility tests for 3's. The divisibility tests for 3's and 9's are the exact same test. Okay? I mean, the process is the same. And they're completely different than any of the other tests. They don't look anything like the other ones we've talked about. We don't care what individual digits are. We care about what happens when we add all the digits' values together. So a whole number is divisible by 3 if and only if the sum of the digits is divisible by 3. And it's divisible by 9 if the sum of the digits is divisible by 9. So if we took either of those numbers or whatever I'm about to create right here, 5, 4, 6, 3, 9, 2, 8, whatever. What we would do to decide if this is divisible by 3 or by 9 is we would add 5 plus 4 plus 6 plus 3 plus 9 plus 2 plus 8 all together. That's what we would do. And whatever we got, we would ask ourselves the same question. Is this number, which will be much, much smaller than the one that's on here, right? Much smaller. Is this divisible by 3? And almost all the time you'll be able to tell that one just by looking. And the same thing for the 9's. I have two more divisibility tests, and they're different than the other two before we do a legit example where I finish it out. So let's take a look at these. These are not on the same slide because they're alike. They're just on the same slide. They're not alike at all. All right, the divisibility test for 11 is the most awkward one to write out, but it's very easy to use. Okay? So here's what it is. It says a whole number is divisible by 11 if and only if the sum of the digits in the places of even powers of 10 minus the sum of the digits in places of odd place of odd powers of division is divisible by 11. I can't even say it, it's so awkward. So write that down, and then I'll show you what it's actually telling you to do. Okay, it's telling you to separate every other digit. The even powers of 10, the odd powers of 10 just mean every other digit. So if I were to separate every digit, I will circle the ones that's every other one. So 5, 3, 1, 2, 6. Whatever they are. I don't even care that you have the same numbers I do. It doesn't make any difference. All the ones I circled are in this case, even powers. And all the ones I didn't circle are the odd powers. So what do I mean by powers? Well, I mean that if you were to write out the expanded notation, this is 10 to the 0 and 10 to the 1 and 10 squared, right? They're powers of 10, the place digits. So what this property is telling you is that if you add all these ones in the gray circle together, you'll get some number. Let's see what I've got from mine. 8, 9, 10, 11. 11 plus 6 is 17. And if I add all the ones that I didn't circle, 4 plus 2 is 6, plus 3 is 9, 9 plus 18 is, or 8 is 17. Interesting. Okay, so this two numbers, if I were to subtract the smaller one from the bigger one, doesn't even matter which one it is, but the smaller one from the bigger one, and these happen to be the same, you'll get a value. You'll get a 0, or you'll get a 3, or you'll get a 19. You might get something larger, but you'll get a value. In our case, we got 0. And if that number is divisible by 11, then the original long digit was divisible by 11. In this case, I get 0. Is 0 divisible by 11? It is. It's like by default. What is 0 divided by 11? It's 0. Yeah, it's not a very exciting one, but it works. So this ugly long number, grab your calculator if you want to check it out and test. I don't even know what I wrote down. Let's see. It looks like 543,213,286 will be divisible by 11, unless I added something up wrong. I guess we're about to find out because Sally got a calculator out. It does. It divides by 11. Sometimes you just make up a number and it works just wonderfully, doesn't it? Okay. The second one on this screen, divisibility test for 6, completely unlike the others. It's kind of a funny test, but we're going to talk about this test because it has other applications that we will see used. It says that a whole number is divisible by 6 if and only if both 2 and 3 divide it. If it's divisible by 2 and 3, it'll be divisible by 6. If it's divisible by 6, it's divisible by 2 and 3. It goes either direction, basically. So, why do you think 2 and 3 are the magic numbers here? Those two numbers multiply to 6. I mean, that is exactly the reason. But you can't do this with just every number. So, what I want to take a moment for you to think about, and just kind of where you are, we've got an even number of people here today. So where you are, and then we'll have, Hannah, you move over here with Mackenzie. I'm going to give you a list of numbers. And I'm going to tell you which ones work like this and which ones don't. And I want you to try and figure out what the difference is between the lists. So I'm going to go to the end of the slides and add it in here at the end. So these are lists of examples. So we have an example that says if it's divisible by 2 and 3, then it will be divisible by 6, back and forth both directions, right? I'm going to give you a couple more. Let's do 2 and 5. That one's 10. Okay? And I'll do 3 and 5 to give you 15. And then we're going to do some examples that don't work. So let's say, for example, I did 2 and 4. And 2 and 4 is definitely the number 8. Right? But just because something is divisible by 2 and 4 does not mean it's divisible by 8. Can you give me an example? What's an example of a number that's divisible by 2 and 4, but not by 8? What is it? 20. Is 20 divisible by 2? 4? 8? No. Okay, let me try another one. Let's go with, hang on, you're going to talk about it with your partner. So I'm just going to give you a couple examples to try and discuss between you, okay? 3 and 6 does not divide by 18. Do you know a number that's divisible by 3 and 6 and not by 18? 24. That's a good example. There's even a smaller one. 12 would work too. Isn't it? Isn't 12 divisible by 3 and by 6? Yeah, but not by 18, right? It's too small. Let's try 4 and 6. These are all ones that don't work, by the way. 4 and 6 does not divide by 24. What's a number that's divisible by 4 and 6 but not by 24? 36 would be one. So would 12. Right? 12 will divide by 4 and 6, but not by 24. So here's your goal. In the next 5 minutes, we'll stop at 2:30. Talk with your partner and see if you can come up with why that's happening. What is it about these numbers that works and these numbers that fails? How are those numbers different? Okay? Here's another one that would work. 4 and 5, 20. That one actually works. Okay, let's hear some ideas. No idea is like a bad idea. I'm sure that you guys have different ones, and I will probably be able to, if you don't have quite the right one that works all the time, I'll be able to show you an example where what you're thinking of doesn't quite make it work. So who would like to give a suggestion? All right, Sally, what's your suggestion?
In my mind that all of the ones on the right can be factored into, so they have factors under them.
Okay.
So like 6 has factors of 2 and 3, so it can be lowered, and then like 4 and 6 can do that as well.
Okay.
And then mostly on the left, except for 4 and 5.
That's why I put it up there for you.
Yes, but you see up there that 2 and 5, it works as well. So that's the only exception in my mind that would work.
Okay, so you have some good thinking along the track, on the right track, is that there is something about the fact that it factors that's useful. But obviously it's not the only thing that matters, because I did give you an example where something did factor into it, you break it down, but when you break it down, it still worked.
Yeah.
What do you think, Hannah?
So like 2 and 4 are factors of each other, 3 and 6, and 4 and 6. Well,
The 4 and 6 don't work. I usually have somebody come up with that idea too. A lot of them will be like that, where it looks like one of them is just a multiple of the other one, but 4 and 6 don't have that property and they still fall in the does not work category. Abby?
4 and 6 have a common factor of 2 though, right?
Okay.
So the ones on that side all share some common factor, and the ones on the left don't.
You're exactly right. Good job. All of the ones in the does not work category have common factors. So they may not necessarily be multiples of one another, but they do have a factor in common. The reason that 4 and 5 here work is because while 4 can break down, it still doesn't break down into anything that's smaller and factors of 5, right? So like I could use 6 and 5 and that one would work. Can you give me an example of another one that would work? Bigger numbers than I've used.
7 and 3.
Okay, 7 and 3 will work. how about 10 and how about 10 and 9? Those are both numbers that break down, right? We're gonna have a name for that pretty soon. But they both break down into smaller factors, but they don't have any factors in common. Can you give me some examples of ones that don't work over here? 8 and 2, okay. 8 and 10. What was that? 10 and 5. Okay, so these lists are indefinite, right? We can keep coming up with more and more examples in these lists, and it all has to do with whether they have common factors. So just a couple of vocabulary things in case I slip up and say them. Numbers that break down like these here are actually have a name. They're called composite. We don't get to it until later. I think next class period, 4.2, we'll get to it. Numbers that don't break down, like 7 and 3, are called primes. And numbers that don't have common factors, which would mean everything over here, all these numbers where there's no common factor are called relatively prime pairs. Usually we don't say the word pairs, but they're relatively prime to one another. You know, it's all relative kind of thing. It's the same idea. It matters who you're paired with, what your comparison is. Okay, so let's go back a little bit then and go back to example number 1 where we're going to test a few of these rules. But I want you to understand that this rule for 6 is not really unique. It's the only one we see, but it works for lots of examples. But the kicker is that the numbers themselves have to have no common factors for this property to work. But as long as they have no common factors, this property holds for lots of examples. All right, we're going to use this number, which is 24,015. And without using a calculator, we're going to decide if it is divisible by 2, 3, 4, 5, 6, 8, 10, 9, 10, and 11. So we're just going to go down the list. And we're going to, in your homework, in your group work, it's just going to tell you to decide. I will tell you that when you get to the test, I'm going to make you justify it. So if you say no, you better be understanding why you're saying no. I would encourage you, whether you write it down or not, I would encourage you to make sure at least mentally you check of the why. Why does this not work, or why does it work? All right, so let's go through the list. 2, does 2 work? No. Why is this not divisible by 2? Right, the last digit's odd. Okay, how about 3? Yes, how do you decide? That's the divisibility rule for deciding if something's divisible by 4, but that's not the divisibility rule for 3. How do we decide if something's divisible by 3?
All the numbers, they both equal 6, and so that would make it 12. So 3
Okay.
divides it.
So remember the rule for 3's is the summation rule. 2 plus 4 plus 0, I know that's not very exciting, plus 1 plus 5 is actually a total of what, Sally? 12. Yeah, so we want the total sum. Is the sum 12? Is it divisible by 3? Yes. So that means the original number is also divisible by 3. How about the 4 then? Caitlin got us started on thinking about the last 2 digits. Remember, that's how we decide on the last 2 digits for the divisibility by 4. No, this one is not divisible by 4. Why? All right, so I'm going to use a little notation for us, get us a little more comfortable. 4 does not divide 15. Do you see my notation? A vertical bar with the line through it. The number we're trying to divide by comes first. 4 does not divide 15. What's next? 5. Yes. Why? Yeah, it ends in 5. 6. We just spent a lot of time on the divisibility by 6 rule. What was it?
It's only if it divides by 2 and 3.
Okay, if it divides by 2 and 3, it's going to divide by 6. Does it? No. So the answer is no, because why? Right, because it doesn't divide by 2. Next one is 8. Unfortunately, we don't have any properties or rules for 7s, but 8. So 8 means taking the last 3 digits, and I did use a small number with a 0 at the beginning, right? 0, 1, 5. So 0, 1, 5, yeah. So 8 does not divide 0, 1, 5 or the number 15. So this one's a no. I forgot my word no. Let me move that over. 9. No, why not?
Because it goes back to when the sum has to be divided by 9 and 12 is not divided by 9.
Right, so the sum was 12 and 9 does not divide 12. But up here, when the sum was 12, 3 does divide 12, right? So you're in the same way, but you're testing it by the 3 or the 9. 10. No, why not? Right. Doesn't end in 0. And then 11 is that truly awkward one we have. So we circle every other number. So that would be 2, 0, 5. So what's the sum of 2, 0, 5? 7. And then I have 4 and 1 at the bottom, or the other two. So 4 and 1 is 5. So in one place value, I have 7, and in one place value, I have 5. So I just subtract big minus small, and I get what? 2. And does 11 divide 2? No. So the answer here will also be no. So in some of your problems, you may be given a whole long list like this, or they may just ask you for a couple of examples, right? They might just say, is this number divisible by 3 or 5? Or is this number divisible by 11 or 10? You know, they might not ask for all of them, but they might ask for a few of them, or they could ask for all of them on a particular problem.
So the homework,
Oops.
you don't need to write justification?
Whatever the homework question actually says is what I go by.
Okay.
So if it doesn't say to justify, I'm not going to make you justify because I feel like that puts you at a disadvantage when the directions don't match what I say out loud. But I will guarantee that on a test, I will always ask you to justify something like this. It's never going to be just yes or no, move on. Yeah. Okay, we're going to take a look at this example, which goes back to this long list that I wrote down here. Okay, so this is an example that applies to these, where it talks about adding numbers together, divisibility rules in that sense. So let's take a look at another example that's not specifically numerical. It says to classify each of the following as true or false. And again, this is an example where it doesn't say you have to justify, right? So if your book doesn't tell you to justify, you wouldn't have to, but I would ask you to on your test. So just make sure that you have a good understanding of why you're saying yes or no. If you're just guessing, it's probably going to not bode well for you in the end when it actually comes time to demonstrate whether you understand the topics, okay? All right, so here's your first one. It says, if a number is divisible by 6, then it is divisible by 2 and 3. That is true. And in fact, that is our divisibility rule in one direction. Our divisibility rules have these phrases that say, if and only if. Do you see that? That means you can go either direction. It means you can start with the 6 and you automatically get the 2, 3, or you can start with 2 times 3, the 2 and the 3, and you automatically get the 6. It means you can go either direction. So that is a true statement. It's one direction of the divisibility rule. Okay? So this is simply the divisibility rule by 6. I'll call it a property. I hate the word rule. Rule sounds like I made it up. Property sounds like it's innately true. And that's actually the true statement here. All right. What about the second one? If a number is divisible by 2 and 3, then it is divisible by 6.
True.
Also true. It's just the other direction of that statement, right? These are the one direction and the other direction of the statements from the divisibility rule. All right, copy paste is a beautiful thing. Do you ever sometimes feel like copy paste on paper when you're writing? Or undo? I try to undo my writing frequently. All right, let's see. If a number is divisible by 8, then it is divisible by 2 and 4. Think about our property for 8. What does our property for 8 say? 3. The last 3 digits as a number have to be divisible by 8, right? So we know we've got something that satisfies that condition. So the question is, does that force it to also be divisible by 2 and by 4?
No, because 2 and 4 is
Correct, and that's exactly why it's going to fail on D,
oh, no.
but it's written in the other direction for C.
Because 2 and 4 are factors of 8.
Yeah, so let's think through let's just write out a list of a few examples. If you wrote down some multiples of 8, 16, what's next? 24.
32,
Let's do one more and then we'll stop. Okay, so obviously this list continues. First question I want to ask you is, are all these numbers divisible by 2? Yes. And no matter how many times I create this list or how far this list goes, am I always going to get something divisible by 2? Yes. Are all these numbers divisible by 4?
Yes.
Yes. And no matter how long this list goes, will they always be divisible by 4? Yes, they will. And the reason is because 2 times 4 is the 8. So if it's divisible by 8, it has to be divisible by all the factors of 8 too. So this one actually ends up being true. So we sort of get like half of a divisibility rule that doesn't exist. But the other half, on part D, is not true. Just because it's divisible by 2 and 4 does not make it divisible by 8. So that's the example that we had looked at on the one where you guys were talking in pairs anyway. Yes?
So if you were going to try to justify C,
Mhm.
like on the first input,
Yeah, so what I would actually put, I was trying to show it with some numerical examples because sometimes that helps us to think about it. But what the reality is that, oh my goodness, sorry, hit the wrong button, is that 8 divides by 2 and 4, correct? Okay, so since 8 is divisible by 2 and 4, we could write 2 divides 8 and 2 divides 4. Agreed? I didn't mean that. 4 divides 8 was the last one I meant to write. It was a true statement, just irrelevant. Okay, 2 divides 8, 4 divides 8. And we had a property earlier, it was over here, that said that if we have 2 divides 8 and we have 4 divides 8, then 2 will divide any multiple of 8, and 4 will divide any multiple of 8. So it's really going back to this property right here. If I have a factor, I'm going to actually be able to have a factor of all of its multiples. So this is theorem 4.1. And of course, on a test, you wouldn't need to say that it's 4.1, but that's for your reference as you're looking at your homework or whatever. False. The easiest way to show that something is false is to give an example that doesn't work, right? Can you give me an example that's divisible by 2 and 4? I like the number 12. I gave that already. Yes, 12 is a good example. 12 divides by 2, 12 divides by 4, but 12 does not divide by 8. Okay? So 2 divides 12, 4 divides 12, but 8 does not divide 12. So it doesn't work in both directions, and it is because of that common factor stuff that we looked at before. Okay, I think we will do one more example and we'll stop there for today. So let's do example 3. Example 3 is a little bit of an odd example. It's using numbers that we don't have divisibility rules for necessarily, at least on A and B, and then C and D something a little bit different. It says to answer each of the following without actually performing the division. So the goal is not to grab your calculator or to longhand divide these out. The goal is to be able to do it mentally, looking at it, being able to just say yes or no, and I have a reason why I said that. And then this one actually says to explain how you did it in each case. So again, that's how it would look if I were asking you. The question is to justify why you're thinking that. All right, the first number is 34,051, and it wants to know if it's divisible by 17. The answer is yes. Any idea why? Or why were you thinking maybe, Sally?
I broke it down into 2 separate pieces because of that 0. I didn't have to worry about it. So 34, if you just double 17, that equals 34.
Mm-hmm.
So, and then I went to 51, and I mentally thought, well, what if I times it by 3 and it just turns out to be
It does. Yeah, and that's a good way of thinking about it, right? If I can break the number up into some pieces that are divisible, then it's going to be divisible automatically. And we actually saw a algorithm for mental mathematics that looked a lot like this back in chapter 2. The end of chapter, not 2, chapter 3, the end of chapter 3, where we did breaking it apart, and we tried to make the numbers that were convenient or easy to use. So the answer here is, in fact, yes. And the reason is exactly what Sally said. Because 17 divides 34, and 17 divides 51. You can break it apart that way. And the 0 in the middle just doesn't affect anything. I mean, you could throw it in somewhere if you want to, but it's just irrelevant, really. So what do you think about 19 dividing 19,031? That's going to be no. Why? So where does it fail then? On the 31. 19 does not divide 31. The 19 at the beginning, we'd be good to go, but the 31 at the end causes us a problem. Yes, indeed. All right, C and D are a little different. They are related to one another, however. Does or is 2 times 3 times 5 times 7, and the goal is not to multiply that out, okay? Is 2 times 3 times 5 times 7 divisible by 5? Yes. Why? That's right, because there's a 5 that's listed as a factor. All right, so yes. There's several things you could write down. I'll write that one down because 5 is a factor. You could also think about, without doing it, what would happen if I multiplied 2 times 3 times 5 times 7 together? Well, it would have to end in 5 or 0, right? Because we know that this number has 5 right in the middle there, and if it ends in 5 or 0, then it's going to be divisible by 5 later. Now, thinking about that logic, what's going to go on D? Is 2 times 3 times 5 times 7 plus 1 divisible by 5? No. That's exactly right. So whatever this thing ends in, it can't be a 5 or a 0. It will be a 6 or a 1, right? Because of that weird plus 1 on the end. So this one is no. And it's because one way to say it is because it ends in 1 or 6. What if this had said, we'll just make up one more small example real quick to think about this. What if this said 2 times 3 times 5 times 7 plus 10? Yes, it would work, right? What if it said plus 5? Yes. What if it said plus 57? No. How are you making the decision?
It has to be like a factor that can be divisible by 5.
Right. And not only that, but you had a property that said that. You didn't think about it too much when we did it, but it's actually these properties right here. These properties say that if you're going to add numbers together, this is what would have to work. And so you'd be giving an example of something, or you'd be trying to find out an example that would be falling in the place right here, the second one. Okay? All right, we will pick up here next time.